to so many different applications, so many different data sets. All right, so what is regression? We're going to cover here regression lines, the least. We're going to look specifically at the least squares regression line. That's a specific type of regression. Technology, you will see some technology in the book, but again, we're not being tested on the technology, just to remind you. And then the facts, about the process of how we get the least squares regression line. Residuals, what they are, what does that mean? Again, outliers and influential observations. We'll be looking at that with, again, scatter plots. This chapter is a continuation of chapter 4, which we looked at scatter plots, where we're studying the relationship between two quantitative variables, one explanatory and one response. And we're going to look and see if there's any outliers or any influential observations. We'll see what those mean too. Cautions about correlation and regression. And of course, a big thing is just because there's an association, it does not imply causation. Doesn't mean that X is causing Y. So we have to be very careful about that when we do these type of studies. And there's a little section there on correlation prediction and maybe big data. I'm not sure if I cover that, but we'll see if we have time. Okay, so here is an example showing regression line. The red line is our least squares regression line, and it's showing if Ni and Ea change is 400 calories, what is the expected fat gain? So we just take 400, go up and find the corresponding fat gain, which would be just above 2. So the purpose of having a least squares regression line, or just simply regression line, is so that we can make predictions using the explanatory variable values within the data set to get response values. Because the data doesn't carry every single possible X value within the data set, right? There might not have been in this case, there might not have been a 400 in the raw data, but we have that line, we can estimate what it would be. Actually, it doesn't have, because there would be a point there for that, right? There would be a data point. The data, the raw data are those points on the scatter plot. Okay. So it's a straight line, and it describes how a response variable changes as an explanatory variable X changes. And we want it to predict values of Y using different values of X. And again, it's the linear relationship. So you probably remembered this equation, y equals a plus bx. You might have seen it as using different letters, y equals mx plus b, right? M was your slope, b was your intercept, right? And you had your x, y. We use a and b, where b is our slope, a is our intercept. So that's how the convention we use in this course, but it's exactly the same thing. It's still a straight line. And when x is 0, we have the intercept a. All right, so that's a review of the straight lines. But the least square regression line is the sum of the squares. We come up with it as the sum. It's not just any line, it's a specific line where we take into consideration all the data points and we find the smallest, the minimum distance from each data point to the line. So it's the sum of the squares of the vertical distances to the line, and we make that as small as possible, and that's how we know exactly where the line will be. Okay, and there's formulas for coming up with the line. We'll see in just a moment. Right here. So we don't just call it any y equals a plus bx. It specifically has a little hat on it. That means it's the regression line, and it's been calculated using the slope b, which is a function of r times the standard deviation of y divided by the standard deviation of x. and an intercept, which is going to be A, which is the average of the y, subtract the slope times the average of the x. So if you have your slope and you have your intercept, you then can put it all together and you have your y hat. We call it y hat. Y hat to denote the regression line. Okay. If we just left it y, then it kind of it sort of gets mixed up with the explanatory variable. It's not an explanatory variable y, it's y hat means it's the line. Okay. And the y's are from the xy pairs. So slope, so we know what all these look like, right? Correlate. So the slope is equal to r times the standard deviation of y divided by the standard deviation of x. We know what all of these look like and how to derive them, more importantly. So here's an example of a least squares regression line. Non-exercise activity example. So they came up with this line, 3.505. That would be our A. That would be our A intercept. And this value here would be our B. I'll put B, which is our slope. And because it has a negative in front of the slope, that means it's a negative slope. And if it's negative, then the correlation will be negative for this data set as well. And we do visually see from the scatter plot, right? We have fat gain in kilometers and non-exercise activity change in calories. You put in, remember that NEA, you might have been wondering what is NEA? Non-exercise activity, NEA, that's what that stands for. From the slide at the beginning of the chapter, 400. So if we have a non-exercise activity change in calories of 400, we can predict a fat gain of just above 2. So y hat, it gives us a y hat. So we would plug in 400. Does it do that on the next? So how would we get that? We would put that in. So y hat, let's do x equals 400. We can see what the y would be. 3.505 subtract 0.0034 times 400. It'll tell us what that value is instead of just looking and saying, oh, it's just above 2. We can actually get the exact value. So why don't we make this a clicker question? It's going to be actually a numeric answer. So clicker question, what do we get when we have y hat equals 3.505 subtract 0.0034? So that is 2.145. And that's where this value is right here. And so we put in 400 here, we output 2.145, and we get this value right here. So this would be 400, comma, 2.145. It's right in the center of the least squares regression line. I'll just put it back there. So that's the purpose. This is, if you understand this, you understand the formulas, that's regression. Okay, so it's not just any line. It has to be the line that goes through the data. It's a line that's fitted to the data where we get the sum of all the just the vertical distances from every point to the line is at its minimum. So these little distances here to here to here See here, like all these distances, even going from the underneath. So some are under the line, some are below the line, some are above the line. And so those vertical distances, we get the sum of those squares to come up with the place and the values of A, the values of B, the slope and the intercept, and then we get the line. And everyone should know how to put a line onto the scatter plot. Just pick some X's and Y's and it will give you the line, right?